Right, so welcome to tonight's lecture. This is a tutorial. We're going to be looking at the exercise that you had because I saw that the performance wasn't good. We were supposed to start integration tonight, but because of the performance, because of how bad the performance was, I'm forced to go back to the exercise and solve it. All right, so there were just about, I think, 5 questions there. Let us do them quickly. So if you have questions, feel free to ask. All right. So the first question was find dy dx. Find dy dx of the function y is equal to ln 1 plus cos 2x at 3 pi over 4. So what you need to understand here is that when you're differentiating a ln function, if you have y is equal to ln, let's say ln x squared, what you have to do, okay, let me just write the general ln, okay, even this one is just okay. What you just need to do is to find dy dx. So to find dy dx, you simply just have to differentiate the function that you've been given. In this case, it's x squared. When you differentiate x squared, you're going to get 2x, and then you divide by the original function, which is x squared. And hence the final answer will be 2 over x. So this is exactly how you differentiate a ln function, meaning you in this case, we're going to differentiate this part and then divide by this same function again. So the derivative of that part, let us say, for instance, we're using chains rule. So for using chains rule, we're going to say let u be equal to let u be equal to 1 plus cos 2x. So when we find u prime, u prime is simply just going to be equal to the derivative of a constant is 0. The derivative of cos 2x, this will just be negative 2 sine 2x. And I'm sure you've gone through the lessons that we've had where I explained how to differentiate trigonometric functions. So like I said, when you're differentiating y is equal to ln, u can be any function. You simply just have to differentiate u, which is just u prime, and then divide by the original function, which is u. So in this case, after differentiating u, we're going to divide by the original function, which is just the same u, this one. So to find dy dx, we simply just have to put u prime on top as a numerator. Our u prime is negative 2 sine 2x, then divide by the original function, which is 1 plus cos 2x. Right. So they are saying we find dy dx at a point where at this point, which is 3 pi over 4 comma 0. So we can change this to degrees if we want our work to be easier. So 3 pi over 4 is simply just the same as 3 times 180, everything divided by 4. So 4 into 18, 4 into 18, that's 4. That's 4. And then remainder 2. 4 into 20, that's 5. So 45 times 3, that gives us 135. So this is just the same as, so if we say dy dx when x is equal to 3 pi over 4, which is just 135 degrees, this will be found by having this. This is sine 2 times 135. So we're going to have 2 times 135 degrees, then everything divided by 1 plus cos 2 times 135 degrees. So this will give us negative 2 sine 135 times 2, this will give us 270 degrees. Then 1 plus cos 270 degrees. So what is sine 270 degrees? We can use the unit circle to find this answer. So this is 1, this is -1, this is -1, that is 1. So we have 90 there, we have 0 degrees and 360 degrees here. Then we have 270 degrees there, we have 180 degrees there. So how do we use this unit circle? We read these coordinates as cos, sine. So the coordinates here are simply just 1, 0, 1, 0. So if, for instance, we say cos 0 is simply just 1, and then sine 0 is simply just 0, because we're reading these coordinates as cos, sine, which is in this case is 1, 0. So when we go to 270, these coordinates as 270 are read as this is 0, -1, 0, -1. So this 0, -1, we read it as cos, sine. So if we want to find sine 270, sine corresponds to -1. So sine 270 is simply just -1. So on top there we have -2, and then in brackets we have -1. Then everything divided by, we have 1 plus, then cos 270 will correspond to this figure there, which is 0. So cos 270 is simply just 0. So -2 times -1, that will simply just give us +2. Divide by 1, the answer will still be +2. So this is the answer that you were supposed to find. Let us quickly move on to the next question. So if you don't have any questions here, we can proceed. But if you have any question, feel free to ask. All right. So we quickly proceed to this question. So this question is, given that y is equal to sine 3x, y is equal to sine 3x. Okay, y is equal to x sine 3x. Sorry, this is supposed to be x, then sine 3x. Prove that the second derivative of y with respect to x plus 9y is equal to 6 cos 3x. So the first thing that we're going to do is to find the first derivative of this and the second derivative of that. So the first derivative of this is simply just we differentiate this, and of course, since we have two functions, we have x and sine 3x, meaning we're going to use product rule, since we have two functions multiplying each other. So we use the product rule. So according to the product rule, we have to find which one is u and which one is v. So our u is going to be equal to x, and then our v will simply just be equal to sine 3x. So u prime, which is just du dx, this one is simply just going to be 1. When you differentiate x with when you differentiate u with respect to x, you are getting 1. And then when you differentiate v with respect to x, so to find v prime, you're going to have 3. The derivative of sine is simply just cos, and then you have 3x there. So where am I getting this 3? You just differentiate this part there. So we use the product rule. The product rule states that dy dx will simply just be given by v, u prime plus u v prime. So we can plug in the values there. So dy dx will simply just be equal to, our v is simply just sine 3x. Sine 3x, then when multiplying this with u prime is simply just 1. Then we have plus Then our u, where is our u? Our u is simply just x. And then our v prime is simply just 3 cos 3x. 3 cos 3x. So when we simplify this, we're going to have dy dx as sine 3x, then x times that will have 3x cos 3x. So let us also find the second derivative of this function so that we come and replace it there. We've been told to prove that this plus that should give us what? 6 cos 3x. So let us find the second derivative of this. So the second derivative will simply just be, since you know how to use product rule, I'll not go through the process again. I'll just do it direct here. So we have dy dx, we're finding the second derivative in this case, d2y dx2 will simply just be equal to, so when you differentiate sine 3x, you just get 3 cos 3x. Then when you differentiate this, you're going to have 3x times 3x times negative sine 3x times negative 3 sine 3x, and then plus we're going to have 3 cos 3x. So I've just used product rule to differentiate this part. Yeah, so when you simplify this second derivative, which can also be written as y prime prime, 2 primes there. So when you find this second derivative, let us just simplify it in short. So 3 cos 3x plus 3 cos 3x, this will give us 6 cos 3x. And then when I add this and that, I'm getting this. Then this other part here, we have 3x times negative 3. We're going to have negative 9x, then sine 3x. So now let us prove that the second derivative, when added to 9 times y, the answer will just be 6 cos 3x. So the second derivative we have found is this one. The second derivative that we have found is simply just this one. So I'm going to write it there. So we have 6 cos 3x minus 9x sine 3x, and then 9 times y. Which one is our y? Our y is simply just there. So we're going to multiply 9 times this y there. So we say plus 9, and then y is x sine 3x, x sine 3x. Then we simplify this now. So we have 6 cos 3x, and then we have negative 9x sine 3x, and then 9 times x sine 3x will get positive 9x sine 3x. So we have 6 cos 3x there. Then when we add this one and that one, we'll simply just get a 0. So we have proved, so this plus 0, the answer will simply just be 6 cos 3x, which is just the same as that. Hence, proved. So this is how you are supposed to find, you are supposed to solve this question. So let's quickly move on to the next question, if there are no questions. Okay, we have this other question which says, given that y is equal to sec x plus tan x, prove that dy dx minus y tan x is equal to 1. So in other words, let us find the derivative of this. Then after finding the derivative of that, we After finding the derivative of this, we simply just replace it there and then multiply y, which is just this expression there, times tan x. We see if it's going to give us 1. So we've been told to prove, meaning it's supposed to give us 1. Okay. So we find the derivative of that. So we have y is equal to, sec x can also be written as 1 over cos x. And then we have plus tan x can also be written as sine x over cos x. So when we differentiate 1 over cos x using the quotient rule, we're going to have, so I'm going to be doing them simultaneously. I'm going to be doing them at the same time. So the derivative of this will simply just be, it's v u prime, which will be cos x multiplied by the derivative of 1 there is 0. So v, which is just the denominator, you can go through the quotient rule. I posted the video in the group. Yeah. So v is simply just the denominator, and then u prime, which is just the derivative of 1, the derivative of a constant number is simply just 0. So I'm multiplying 0 times cos x, and then I'm going to say minus, my u is sine x. My u is sine x. Oh, wait. My u is 1. I moved on to this one. So, okay, my u is 1, and then 1 times the derivative of cos x is simply just negative sine x. So we say minus, and then open brackets, we have negative sine x, which is the derivative of v, and then multiplied by 1. Then everything divided by v squared, which will be cos squared x. And then we have a plus there. We also differentiate sine x over cos x. So our v is simply just cos x. Yeah, our v is simply just cos x. Okay, I think the best way we can simplify this, instead of us maybe complicating things, let us combine these two expressions, because I've just discovered that the denominators are the same there. It's going to be a bit easier than what I'm doing here. So let us just combine the two expressions. So this can also be simplified as, okay, let me just erase this same part. So we have y is equal to, the common denominator is simply just cos x. So cos x into cos x, the answer is 1. 1 times 1, we get 1. Then we have plus cos x into cos x. The answer is 1. 1 times sine x. This will give us sine x there. So we have 1 plus sine x there. So let me even now use the quotient rule step by step, so that even those that were not there can understand what I was doing. Okay, so according to the quotient rule, the numerator is the one that we get as our u. So we say u is equal to 1 plus sine x, and then the denominator is going to be our v, which is just cos x. So u prime will simply just be equal to, the derivative of 1 there is 0, and then the derivative of sine x is simply just cos x. So u prime will simply just be equal to cos x. Then we also find v prime. So v prime is simply just negative sine x. So now we put in the formula of the quotient rule. So the quotient rule, is simply just dy dx is equal to v u prime minus u. So this is u, v prime, everything divided by v squared. So we plug in the values there. We're going to have our v is cos x. So our v is cos x. Then u prime is cos x as well. And then we have a minus. Then our u is simply just 1 plus sine x, 1 plus sine x. And then v prime is simply just negative sine x, negative sine x. And then everything divided by v squared. So our v is cos x. So when we square that, we're going to get cos squared x as the denominator. So let us simplify this. So simplifying this, we get dy dx as cos x times cos x. This will give us cos squared x. And then we say minus, when we multiply this negative and that negative, meaning we'll have a positive here. Or let me, okay, yeah, we'll have a positive there. And then we say sine x times 1 there will get sine x. And then we have sine x times sine x there will get positive sine squared x. Then everything divided by cos squared x. So this part, this one, cos squared x plus sine squared x, this is a Pythagorean identity which gives 1. We know to say cos squared x plus sine squared x is equal to 1. It's a Pythagorean identity. You just have to master it. So this one gives us 1. So this part and this part, when you combine them, we'll get a 1. So we'll have a 1 there, then plus sine x there as a numerator, plus sine x. Everything divided by cos squared x. So this is what we have gotten as our dy dx. They are asking us to say, we prove that when we write our dy dx there, and then we subtract y times tan theta from the dy dx, the answer that we're going to get is 1. Let's see if it will give us 1. If it will not give us 1, then we have made a mistake somewhere. Now, let us see what we have answered, and then we plug it there. So dy dx is exactly what we've just found here, which can also be splitted and written as 1 over cos squared x, 1 over cos squared x, and then plus sine x over cos squared x. I've just splitted this same dy dx down here. So I've splitted it into 2 independent terms. Then let me write now the minus, this minus there. Then the y, which is there, I'm just going to get everything there. So I'll put them in brackets. I have sec x, and then plus tan x, and then I'm multiplying everything with tan x. So let us prove that this is equal to 1. So this 1 over cos squared x can also be written as sec squared x. And then this one here, sine x over cos squared x can also be written as sec squared x times sine x. And then this sec x times this sec x times tan x, sec x times tan x, this one, I don't know, maybe let me just erase this part here. Let me just erase this part. Okay. Let me just erase this part so that I can be showing you how things are coming out there. Okay. So these are very simple and straightforward questions. Shouldn't be finding difficulties answering such questions. These are the questions that you should get as free marks when you find them in an exam. These are free marks. So because you've already been given the answer, what you just need is to show that what you've been given is equal to that answer. So meaning if you find a different thing, then you know that you've made a mistake. You go back and you go back answering the same question again. You make sure that you find the final answer. These are 3 marks. Okay, so I was saying sec x times, so let me write the minus in advance there, and then I'll open the brackets. So sec x times tan x, sec x times tan x can also be written as, we know that sec is 1 over cos x, and then tan is sine x over cos x. I hope you are seeing what I'm writing. Let me just put them in brackets like this. Yeah, so when you multiply the two, you're going to get something like 1 times sine x there, you just get sine x. Then everything divided by cos times cos, you get cos squared x, which can also be written as sec squared x times sine x. Okay, so I'll write my sec squared x there times sine x. And then when I multiply tan times tan, I'm going to get tan squared x. So I'll say plus tan squared x. So we can open the brackets. I have sec squared x plus, then we have sec squared x sine x, then minus, when you multiply this minus times sec squared x times sine x there, you get sec squared x sine x. Then we have negative times tan squared x there, you get negative tan squared x. So you can see that this one and this one, they're subtracting, they're giving us a 0. So we have just remained with sec squared x and negative tan squared x. So is this a 1? Yes. How is it a 1? We go back to trigonometric identities. So I told you that you should make sure that you visit trig identities, very important. So trig identities, we get the Pythagorean identity. We have cos squared x plus sine squared x is equal to 1. So when we divide everything by cos squared x, divide by cos squared x, divide by cos squared x, cos over cos will get 1, and then we have a plus there, which is just this one there. And then sine over cos, we get sine over cos is simply just tan. Because there's a squared there, I'll put a squared there as well. 1 over cos squared x is simply just sec squared x. So this is equal to sec squared x. So when I take this tan squared x to the other side of the equal sign, I'm going to have 1 this side is equal to, this side will have sec squared x. Then when tan goes to this other side, we're going to have a minus tan squared x. So we can see that this part is exactly the same as that part which I've found there. Meaning while there's this part in this expression, I can just replace that with 1. So meaning the final answer here, sec squared x minus tan squared x, the answer is simply just 1. So you see how simple these questions are. Very simple and straightforward. Yeah, so this is exactly how you solve such a question if you met it somewhere. All right, so do we have any questions before I can proceed? All right, so there are no questions. We move on. So we have this other question. So this one is differentiate sine x over 1 minus cos x, and hence show that the derivative of the ln of this question is simply just equal to negative cosec x. So this one is straightforward as well. So we differentiate this expression since there is since we have two functions dividing themselves, you simply just use what is called the quotient rule to differentiate the expression. So the numerator there becomes our u, which will be sine x. U becomes sine x, and then v is equal to 1 minus cos x. Yeah, so we find u prime there, we get cos x, and then v prime is equal to, when you differentiate this, you get sine x as your v prime. So when you plug in these values in the formula, you discover that the value, your dy dx, if for instance this was equated to 1, or maybe your, let's say, d sine x over 1 minus cos x dx, this one will simply just give you you put your your values in the quotient rule formula. So we put in all these values that we found. So our v is simply just 1 minus cos x. Then we're multiplying this with u prime, which is just cos x there. And then we say minus our u is simply just sine x, and then we're multiplying this with our u is simply just sine x, and then we're multiplying this with v prime, which is also sine x. Then we divide everything by v squared. So our v is 1 minus cos x, and then we square this. So to find the final answer, when you open the brackets there, you're going to have cos x minus cos squared x, and then minus sine squared x. And then everything divided by 1 minus cos x, then squared. So when you simplify this, you can have cos x, we factor out the negative there, we remain with cos squared x plus sine squared x in the brackets. So this is divided by 1 minus cos 1 minus cos x squared. So we can see that what is in the brackets there is just a Pythagorean identity, which gives us a 1. So on top there, we'll remain with cos x minus 1, and then the denominator will be 1 minus cos x, of course, everything squared like that. So when we simplify this, we can factor out the negative, we can factorize the negative on top there. So when you factorize the negative on top, you're going to have negative 1 outside, and then in brackets, you're going to have 1, positive 1, and then the cos will become negative. So the cos will be negative cos x there. And then everything divided by 1 minus cos x, and then this one squared. So you can see that this one and one of these will cancel, meaning we just remain with negative 1 on top, and then the denominator will simply just be 1 minus cos x. So this is the derivative of this function there. So now let us find the derivative of the ln of this same function. Remember, if you have, or if you are differentiating a ln function, which is in the format y is equal to ln u, you simply just, to find y prime, you simply just say u prime over the original function, which is u. So you differentiate the function that you have there, divide by the original function. So when we differentiate this function, we are getting this part here down. And then we divide by the original function, which is this one there. So we are going to say this, this part is just that we don't have enough space here. So I was supposed to write this whole thing. I'll write it, and then I'll say this whole thing is equal to, so this whole thing is going to be equal to -1, which is the derivative of u, which is the function which is inside there. This -1 over 1 minus cos x, and then this, and then divide by everything, divide by the original function, which is sine x over 1 minus cos x. So when we divide this, mathematically, you can see that this and that will cancel. Yeah, it's just that we don't have enough space. I would have shown you how they are canceling. So just remain with we'll just remain with -1 over sine theta, sine x, sorry. So -1 over sine x is also just equivalent to negative cosec x, which is just equal to what we have found, what we were told to find there. So this is how you solve such questions. So let me generate another link so that you can join. We'll finish up the 2 questions that are remaining.